Our last topics was problem 1. In problem 1, one circuit of a single phase transmission line is composed of three solid 0.25 centimeter radius wires. The return circuit is composed of two 0.5 centimeter radius wire. The arrangement of conductor is shown in figure 1. Find the inductance due to the current in each side of the line and inductance of the complete line in henries per meter and millihenries per mile. Here my roll number: P equal to 4, Q equal to 1, R equal to 0, S equal to 1. Here P by S means 4 by 1. If I divided 4 by 1, I get 4 meter. The distance AD, the distance AD is 4 meter, and if Q is here 1 and R is here 0, but if I 1 divided by 0, I get infinity, so I divided 1 by 1 and I get the result is 1 meter. Here AB is 1 meter, as like B and C also 1 meter inside X. Now I get the solution. The GMD between side X and Y, DM equal to root over 6 DAD DAD DAC DAE DAE DBD DBD and BE means 4 meter, and DCD CD and DCE CE. Here we DAD equal to 4 meter, DAE here AE DAE here AE AD equal to 4 meter and AB 1 meter. So we use the Pythagoras rules. 4 square, say as per same BD 4, here BE equal to 4, and CD equal to 1 plus 1 whole square plus 4 square root over into ECE. Okay, we get the result 4.137 meter. The GMR for side X, here the DM, the both side of X and Y, and the GMR for X equal to DS. Here X side is 3 point ABC, so we get the value of 9 root over 9 equal to DAA DAB DAC DBA DBB DBC DCA DCB DCC. Here DAA means the radius 0.25 we convert it centimeter to meter, 2.5 into 10 to the power minus q, into DAB equal to 1, DSC equal to 2, plus DBA equal to 1, DBB equal to 2.5 into 10 to the power minus 3, into DBC equal to 1, into DCA into 2, into DCB equal to into 1, DCC into 2.5 into 10 to the power minus q, and we get the result equal to 0.158 meter. We know the rules. Lx equal to, if we will get the inductance, we follow the rules. Lx means inductance equal to into 10 to the minus 7 ln into dm by ds Henry per meter. This is the rules. We use the rules for the calculation. Equal to 2 into 10 to the minus 7 ln into dm. Here dm equal to 4.137 meter and ds equal to 0.158 meter. If we calculate this equation, we get 6.530 into 10 to the minus 7 Henry per meter. Again, the GMR for side y, here y is 2 point, d and e, so we get the 4 value, d d d d d e d e d d e e. So we submit the value and calculate the equation. Here DDD, the radius of the DD point is 0.5 meter centimeter. We get it here. The two composite 0.5 centimeter radius. So we convert it meter, 5 into 10 to the minus 3. And DE equal to 1, DED equal to 1, DEE equal to 5 into 10 to the power minus 3, equal to 0.0707 meter. And for the inductance of y side, we use the same rules, follow the rules and get the result. Here dm is fixed for x and y, 4.137 divided by ds equal to 0.070 Henry per meter, equal to 8.138 into 10 to the minus 7 Henry per meter answer. This is our y side answer, and this is our x side answer, 6.530 into 10 to the minus 7 Henry per meter. Thank you all. This problem solution is all about. Again, thank you everybody. Good day.